The next thing we need to talk about is how we describe a chemical reaction. So let's define what a chemical reaction is. So a chemical reaction, this is a process in which a substance is changed into one or more new ones. So a process by which a substance or substances is or are changed into one or more new substances. Okay, and so to describe a chemical reaction, we write a chemical equation. All right, so let's talk about this. So here's one. You've got 2 moles, or 2H2 plus O2 yields 2H2O. And so if we were to read that into plain speak, that would read as molecular hydrogen reacts with molecular oxygen to yield water. Now the 2 in front of the hydrogen and the 2 in front of the water, that's called a coefficient. And we place the numbers in front of compounds to help us balance a chemical equation. Now everything to the left of the arrow is called reactants. Everything to the right of the arrow is called products. The plus sign means react with. The arrow means to yield. All right. Now, with a chemical, while that's pretty close to a final equation, there's actually one part missing. We can actually specify the state of matter. And so that's the other thing that's missing from this chemical equation. So we can specify the state of matter. Okay, and so we write in parentheses an S. We could also write in parentheses an L, and we can also write in parentheses G. So when you're dealing with an S, that's a solid, L, liquid, and then G, gas. Now, there is another label that we could potentially use, and that's called aqueous, which is AQ. Okay. Aqueous means that the substance has been dissolved in water. Okay, so for instance, if I wrote NaCl, AQ, what that's saying is that this is a solution of sodium chloride in water. Okay, now in chapter 4, that's pretty much what we're going to be talking about, what aqueous solutions are. All right, so this really, writing a chemical equation really helps us out in lab, because what if, let's say you have potassium bromide, which has this molecular formula of KBr, okay, and you mix a solution of KBr, so let's call that aqueous, with a solution of silver nitrate, AgNO3. Is there a way to predict the final products? Absolutely. So there's actually a pattern to the reactions that we see in chemistry. So let's talk about this real quick. So there's 5 major types of reactions that we see, and we're going to talk about now. We're going to add a couple more to our repertoire in the next chapter. So the types of reactions that we see, the first one is called a composition reaction, where if you have element A reacting with element B, it produces compound AB. Okay, so that's composition. Sometimes this is also called synthesis. The opposite of composition is taking a compound and breaking it up into its elemental parts. The opposite of composition is called decomposition. Okay, so we have composition, we have decomposition. What if you have a compound AB, and then you're going to add in another element, and I'm going to call this one C. So what happens is that C ends up replacing A. So we get compound CB, and an element A is replaced. This is called a single displacement reaction. So sometimes it's called single displacement. Some books also call it single replacement. Whichever way you want to call it. If you have two compounds, compound AB and then compound CD, you could actually have the A's and the C's replace each other. And so you would get compound AD and then compound CB. This is called a double displacement. Okay. Finally, if you have an organic compound, so you have carbon and hydrogen, okay, and you react that in the presence of oxygen gas, you're going to form carbon dioxide and water. And so this is called a combustion reaction. All right, so let's try this problem out. All right, so solid calcium phosphate and aqueous sulfuric acid solution react to give calcium sulfate, which comes out of the solution as a solid. The other product is phosphoric acid, hydrogen phosphate, which remains in solution. Write a balanced chemical equation for the reaction using complete formulas for the compounds with phase labels. All right, so in order to tackle this, what we need to do is write the chemical formulas for each of these compounds. So for the first one, calcium phosphate, the cation is going to be calcium, and then phosphate, the polyatomic ion for phosphate is PO4, 3-. So this compound, when it comes together, if you crisscross the charges, you should get Ca3 and then in parentheses PO4 2-. And so that would be your first compound. For sulfuric acid is H2SO4. Okay. The next compound is calcium sulfate. Calcium, again, would have a 2+ charge. Sulfate ion is SO4, and that has a 2- charge too. So when you use the crisscross rule with these, the charges cancel out to give you CaSO4. And then the last one is phosphoric acid, which is H3PO4. All right, so let's write what we've got. So we've got Ca3PO4, and it said solid. So I'm going to write this as a in parentheses S plus sulfuric acid solution, so H2SO4, and that's going to be aqueous because it's in solution, yields calcium sulfate, which is going to be CaSO4, and that's going to be a solid. And then the other product is phosphoric acid, H3PO4, and that's going to be aqueous. So we're really close in balancing and having a final equation where we just have to balance it now. So let's take a look at this. Usually what I do is start from left to right. So you've got 3 calciums on the right. You've got, on the left, you've got 1 on the right. So I need to put a 3 in front of calcium sulfate so that way the calciums are balanced. You have 2 phosphates on the left. You've got 1 phosphate on the right. So to balance that, I need to put a 2 in front of phosphoric acid. Now that's going to throw off the hydrogens. 2 times 3 is going to give us 6. So you've got 6 hydrogens on the right, 2 on the left. So I need to multiply H2SO4 by 3. So that gives us 6 hydrogens And then that also gives us 3 sulfates. You got 3 sulfates on the right, and so that's your balanced chemical equation. Now, finally, before we get off of this, let's talk about balancing a combustion reaction, because sometimes this takes a little bit more patience. So let's talk about this. So here's your compound, C4H10 plus O2 yields carbon dioxide and water. So what we're going to do is balance the carbon, balance the hydrogen, and we leave the oxygen for the very end. And I'll show you why we do that in a second. All right, so let's balance this. You've got 4 carbons on the left, 1 on the right. So I need to put a 4 in front of CO2. All right, so you've got hydrogens. You've got 10 hydrogens on the left, 2 hydrogens on the right. So I need to put a 5 in front of the water to make the hydrogens balance. So now let's deal with the oxygens. You've got 2 on the left. You got 4 times 2, which is 8, plus an additional 5. So 8 plus 5 gives you 13. So you've got 2 on the right, on the left, and then you got 13 on the right. So to make things balanced, we can write this as a fraction 13, which is the 1 on the right, divided by 2, which is the number on the left. Okay, so that, including the 1 for butane, this is technically a balanced chemical equation. Now, the only problem is you got a fraction as a coefficient, and usually we don't want fractions. So we got to get rid of that fraction. The way we do that is to multiply this coefficient by its denominator. So if we multiply this by 2, that gives us 13 moles of oxygen. But if we multiply that one by 2, we have to multiply all these other numbers by 2 as well. And so the ratio of these coefficients would be 2 to 13 to 8 to 10.